Yeah, so we have lead nitrate, potassium iodide, and we are going to say that both of them in this example are going to be compounds. We are going to say that they're compounds because why? Both of them are made up of more than one element, right? So they're compounds because they are made up of more than one type of atom. Okay, in both cases. We're going to focus first of all on the lead nitrate, and I'm going to say that lead, I'm going to start with a square, and nitrate, I'm going to start with a circle when I go ahead and I draw it out. Now, the next thing I'm going to do is show you what lead nitrate looks like. And this is what lead nitrate looks like. So, this, please, I know the temptation to talk is great, but I need to get through this today. So, what obvious observations were people making as I walked around with this? It is clear. Hold on, we'll get to that in a second. So we'll say it's clear. Does it have a color? We would say it's colorless. Now, what state of matter or type of matter rather would this be? I hear a lot of you saying liquid, and I'm going to say it's not. This is not a liquid. It's not a gas. It's also not a solid. So if you go back in your notes real quick once, what could this be? Yes, a solution, right? So this could be a solution, which is also called aqueous. Okay, so it's a clear, colorless solution. And if it's a solution based on what we talked about before, or the other day, what does that mean is true? Go back and look in your notes. What is a solution really? What is a solution? What? We talked about it on Friday. Yeah, it's a pure substance that's dissolved in water, right? Okay, so when I go to draw this, I'm going to draw this like a compound, and when I draw it like a compound, that means I'm going to do what to the circle and the square? And I'm going to put them next to each other and close. He said equal amounts. Connect them. Thank you. So what I'm going to do is I'm going to draw like 5 leads or 5 squares. I'm going to draw like 5 circles, which are supposed to represent nitrate. And then I'm going to connect them. And then the last thing that we're going to do is what we said is that when it's a solution, it means that the substance has been dissolved in water. So I'm going to represent water with an X. And I'm going to surround all of these substances or all of these particles of lead nitrate with water. Okay. Now, the next substance that we're going to be looking at is the potassium iodide. And the potassium iodide, I'm going to say that I'm going to represent the potassium as a triangle, and I'm going to represent the iodide as a star. And so I'm going to come around and show you guys what that looks like. So in this instance, what I'm going to do when I draw, so what are the observations that we make about this? A lot of you said it looks exactly the same. So we could probably make the same set of observations. It is clear. It is colorless. And I'm going to argue that it's a solution, which means it's aqueous. And so I'm going to essentially draw the same thing, okay? But I'm going to use the triangles and the stars. So I'm going to start with my triangle. I'm going to add my stars. I'm going to connect them with a line to indicate that they are a compound. And because they are a solution, I'm going to surround them with X's. Like this, making sure that they are completely surrounded with water, indicating that they've been dissolved. Now, here's the lead, and here is the potassium. And we'll walk around and show that just for prosperity. So in this reaction, I'm going to combine the lead nitrate and the potassium iodide. So I'm going to pour them together like this. And so hopefully you can see that. So you guys all made some big observations. This is one that was done earlier today. And I'm going to walk around and have you take a look at it, but I just wanted to show or illustrate that that's a thing. So some obvious observations that we made was that there was an obvious color change. I heard a lot of people say that. From clear to yellow. What else could we make an observation about? So what state of matter would you describe chunkier? Solid. A solid was formed? Any description of said solid? It appears powdery a little bit. And then what about the liquid on top or the solution on top? Like clear. Well, so we're going to say that the solution is mostly clear. Okay. Now there are some things that I can tell you that are a fact.
Wait, what does that say after solid the solution?
Solution is clear. I'll make that better. Now, I can tell you for a fact that some of the elements switched places in these solutions. So when I took these two solutions and I poured them together, the elements switched places and became clearly a new compound. So what type of a reaction is this? Physical or a chemical change? This is definitely a chemical change. It's a chemical change because of an obvious color change. And a new substance was formed. Okay. Now, I'm going to tell you that essentially the lead or the green squares changed places with the red triangle or the potassium. So when I draw this, it's going to become, there's going to be, oh wait. Also, I can tell you that the lead and the iodine, this new compound that was formed, is the solid at the bottom. So I'm going to draw it to look something like this. And so I'm going to combine it with the star. They're going to touch and be ordered. And I'm going to link them together. And note that the number of green boxes, the lead, and the number of orange stars, the iodide, are the same on both sides of the arrow. I'm going to also make note that the fact that the triangles and the purple circles are now represented, but they're in that solution. So I'm going to have my red triangles. And they are going to be paired up with the purple circles. And I'm going to connect them. And then because we had water at the beginning, we need to have water at the end. So we're going to surround the potassium nitrate particles with X's, indicating that they are dissolved in that water, creating this solution from before. So in this drawing, I have a solid represented and I have a solution represented. Questions about that? Okay. Now, we're going to talk about zinc and hydrochloric acid. So, we have zinc, we have hydro, and we have chloric. So that tells us some things. And I'm going to grab some zinc for you to take a look at. So zinc looks something like this. So I took the zinc and I put it in this test tube, and we'll talk about that in a minute. But the zinc itself, what type of a substance is it? Is it a solution, or I'm sorry, is it a mixture? Is it a pure substance? Is it an element?
It's a solid.
It is a solid, but more specifically, is it an element or a compound or a mixture? It is an element. So we'll say that zinc is an element because it's made up of only one type of atom on the periodic table. Okay, now I'm going to represent zinc as a square. And so I'm going to draw some zinc in the bottom here. And the observations that we had made, I heard a lot of people saying it was a solid. What else? What other observations did you make? We would say maybe gray, less than silver, but we'd say gray. Oh, he said it looked like the texture of a crayon. So there is some chalkiness. So it's gray, white, chalky. Okay. Now, the next thing we're going to talk about, I'm going to show you is hydrochloric acid. Okay. And I'm going to tell you that hydrochloric acid is made up of hydrogen and chlorine. Okay. I'm going to draw chlorine as a triangle, and I'm going to draw hydrogen as a circle. And so the observation for hydrochloric acid might be something that looks like this. So we wandering around, what observations did you make about the hydrochloric acid? Colorless? What else? Is it a liquid?
Liquid. It's a liquid. Also solution.
It's a solution.
Right.
So that means it's aqueous. Did it appear that you could see through it or no?
Yeah, you can see through it.
So we would say it's clear. Okay. Now again, I'm telling you this is a solution. So when I draw this, I'm going to take the circle and the triangle, and I'm going to draw them, and I'm going to have them, for lack of a better term, bonded together or connected. So that would look something like this. And then I'm going to connect them, indicating that they are bonded together. And then because we said it's a solution, we're going to surround those particles with water. She's not here today. Now, the next thing I'm going to do is I'm going to mix these two things together. And that's going to look like this. Ready?
Whoa.
So some obvious things that we notice is that there's definitely some heat occurring here too. So, all right, now, what observations would you make that are obvious here? Okay, so bubbles formed, heat was produced. What else appears to be given off? So a vapor produced. I heard somebody say there was an odor produced. Okay, now there's one more thing I want to show you. So the last thing that many of you made observations about is it appeared that the zinc went from being somewhat gray to somewhat black, right? So it looks like the zinc changed color. Okay, now things I can tell you. The zinc is still present. Okay, so I'm going to draw, and it's still solid, so I'm going to draw some zinc at the bottom. Okay. I can also tell you that there was gas produced, right? And of the things that are left, hydrogen and chlorine, which one of those do you think became the gas?
Hydrochloric acid.
Which one of them became the gas? Hydrogen most likely became the gas. So that means that the chlorine is still left around, right? And that means that it paired up with something else in this reaction, which happened to be some of the zinc. So that would look something like this. And I'm going to connect them. And then I'm going to draw this little line here to indicate that the gas has escaped, the hydrogen has escaped to the atmosphere. The zinc and the chlorine are now are in the solution part, and the zinc that did not get all used up is in the bottom. So that means that there has to be some water here, because this is definitely a solution. So there's a lot of things going on in this reaction that we need to keep track of. Now, what type of a change is this? Chemical or physical?
Chemical.
How do you know?
Bubbles form, odor produced, color change, all the stuff you put about.
Yeah. So formation of a gas. Formation of heat. Color, obvious color change. Now, here's one that was done earlier today. And it looks something like this. So those are the 4 demos that we were going to talk about in class yesterday or Friday and today. The big point of this was your ability to draw model of matter diagrams for different types of matter. We had elements, we had compounds, we had things that were solid, we had things that were liquid, we had things that were gas, we had things that were aqueous. And so all of those things we're going to have to be able to keep track of, and it's a skill you're going to have to be able to do a big chunk of the rest of the year. Questions?